Alright, this is 6.6, which is the last section of Chapter 6, dealing with bond energy and using that to find enthalpy change of a reaction. So bond energy is pretty simple. It takes energy to break the bonds, therefore it's endothermic. And then when you form bonds, it releases energy and it's exothermic. So if a reaction is exothermic, that means the new bonds are greater than the old bonds, and you get a negative number. If the old bonds are greater than the new bonds, you get an endothermic reaction. So here are two examples. An exothermic reaction, the combustion of methane. It takes energy to break the CH bonds and the double bond O's. And then when they form water and CO2, you get an exothermic forming of bonds, and the net energy is negative, so it's exothermic. On the other hand, if you were to break HBr, it takes a lot of energy, and then to form hydrogen and bromine, it doesn't take a lot of energy, so the net energy is endothermic, positive. In reality, all reactions, not all the bonds in a compound are going to break and then reform. You have sometimes an equilibrium. We'll get to that when we get equilibrium. And that's because some bonds in a reactant need to be broken and form new ones in a specific sequence. And we'll get to that as well. The energy to break a bond is called the activation energy because it activates the reaction. Bond energy is the amount of energy needed to break a specific covalent bond. So for example, a CH bond is the amount of energy to break a single bond per mole between carbon and hydrogen. To break bromine, to make 2 Brs, it takes 193 kilojoules per energy. To break an oxygen molecule, it takes more because of that double bond between the O's. Energy is always positive because it refers to breaking the bond, so you gotta put energy in. When new bonds are formed, the amount of energy released is always the same as energy absorbed when the same type of bond is broken. So if you were to form oxygen, it would be negative 498 kilojoules because it's exothermic. And bond energy, they are affected by different molecules. So an OH bond could be different between the first and the second of different molecules, and even between the first and second types of bonds. And that's why it's called an average bond energy. It's not specific to one particular compound, it's the average. Alright, so how do you find it? Pretty simple. You can calculate enthalpy by taking the energy to break the bonds minus the energy to form the bonds. So reactants minus products. So here we'll go to the active board. And we have nitrogen forming and hydrogen bonding to form ammonia. So, and you have the good idea in any of these problems to draw the structural formula, the structural compound of either the molecule or compound. So nitrogen would look like that, and you have 3 hydrogens, and you're forming 2 ammonia groups. So the reason why you do this is to show that you have the different types of bonds and you can count how many bonds. So for nitrogen, it's 945. There's only one of them. Hydrogen, there are 3. So you're going to multiply 3 by 436. And in ammonia, there are 1. 2, 3, 4, 5, and 6 bonds. So it'd be 6 times 391. So you do delta H is your reactants. 3 times 436 plus 945. 2253 minus 6 times 391. 2346. And your difference is negative 93 kilojoules per mole. Okay? Alright. Next example is the combustion of ethanol, making CO2 and water. So A, you always want to rewrite, oops, my bad, there you go. Rewrite the equation. And go right here. So we want to draw ethanol. Three oxygens. 2 carbon dioxides. And 3 waters. Okay. There are 1, 2, 3, 4, 5 CHs. There's 1 CC, 1 CO, and 1 OH. CC, CO, OH. There are 3 O's. 1, 2, 3, 4 OCs. 1, 2, 3, 4, 5, 6 HOs. Okay. So you look for your chart. CC is 347. CH is 410. CO is 336. And OH 465. Double bond O 496 multiplied by 3. Oh, we gotta multiply these by 5. Double bond O or CO 805. 4 of those. And OH 6 times 465. Alright. What do we get on your reaction side? Four, 6, 8, 6. And on the product side, 6, 0, 10. Negative 13, 24 kilojoules per mole. Alright. So that is it for chapter 6. If you have any questions on the examples, we can